Example 3 says find the indefinite integral of 4x e to the x squared. Again, we definitely have a exponent here on e to the x that is not just x, so we need to make that. Try u substitution as our goal, and we're going to make whatever that exponent is to be u. So in this case, u would be x squared. Again, take the derivative with respect to x of both sides, so du dx would equal 2x. We're going to solve for dx by multiplying both sides by 2x. Dx dividing both sides by 2x, so we'd be left with a du over 2x. We're going to substitute in for u, and we're going to substitute in for dx, and rewrite our original integral. So if we're rewriting our original integral, I'd still have the integral of, well, 4x is still left, but then it's e, and instead of x squared, that's our u, and then dx was du over 2x. Let's see what happens. Looks like our 4x and our 2x are going to simplify. I'm going to be left with a 2 out of that. I'm going to pull that constant out in front, so that's 2 times the integral of e to the u du. Now our variable and our differential match, so we can integrate. So this would be 2e to the u plus c, because the integral of e to the u is e to the u. That last step is back substituting for that u. So I'm going to have 2e to the x squared plus c. We want to check our answer to make sure that's right. The derivative of 2e to the x squared would be 2e to the x squared times the derivative of the exponent using the chain rule, which would be another 2x. So 2 times 2x gives us the 4x. So we would have 4x e to the x squared. So that is the correct answer. Let's look at the next one, which highlights log rules. If you remember, the derivative of the natural log of x is 1 over x. Let me write that down again to just remind us. The derivative with respect to x of the natural log of x was equal to 1 over x. So if I want to do the antiderivative of 1 over x, I have to get the natural log of x plus c, but there's one problem. We got to remember that our domain for the natural log was restricted to positive values. Again, the only x values that you can plug in for a natural log is positive values. So in order to compensate for that, what we do is we use an absolute value when we integrate it. So the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. And I do want to tell you, a lot of people do this one wrong because they try using the power rule. Let me show you what that would look like. If we looked at the integral of 1 over x dx, if we looked at that as the integral of x to the negative 1 dx, and we use the power rule, what you would end up with is x to the, well, you need to add 1, so it would be x to the 0 over 0. Well, anything raised to the 0 is 1, so this is 1 over 0, but this is division by 0, so that's undefined. So the power rule does not work when you have 1 over x. That's the only power of x that it does not work for. So if you have 1 over x, that is the antiderivative of 1 over x with respect to x is equal to the natural log of the absolute value of x plus c. The second part here just says, yes, it works with u substitution as well. So let's go ahead and take a look at some of these examples. Example 4a says the integral or antiderivative of 2 over x dx. Well, this is the same thing as 2 times the integral of 1 over x dx. Just pull that constant out in front. And we know that the integral of 1 over x is the natural log of the absolute value of x plus c. Yes, you do need the absolute values, or no, I cannot count it as correct. So make sure anytime you have a natural log, when you're doing your integration, that you put that absolute value there. Okay. Let's look at b. It says, what's the integral of 3x squared over x cubed? 3x squared over x cubed, this is kind of a play off of the quotient rule, seeing that there's a fraction, but always try to simplify first if you can. So x squared over x cubed, that really turns into a 1 over x. So really this is the integral of 3 over x dx. But again, what you can do is pull out that constant multiple. So it's 3 times the integral of 1 over x dx. And the integral of 1 over x would be the natural log of the absolute value of x. Then you have your plus c. So this would be 3 times the natural log of the absolute value of x plus c. Again, anytime we get one of these answers, we can quick mentally check it. 3 times the natural log of x, the derivative of the natural log of x is 1 over x. So that would be 3 times 1 over x, which would be 3 over x. And our original problem simplified to 3 over x, so we know we have the correct answer. Let's go ahead and look at that last example here. How about c equals the integral of 2 over 2x plus 1 dx? This one is a nice hidden example of the log rule. So if you only have a number in the numerator and a single term in the bottom, in the denominator, you might want to try u substitution here. What should you use for u? Again, you should use the highest power of x term for the u. So let's give this a try. Let's say u equals 2x plus 1. We're going to take the derivative of u with respect to x, take the derivative with respect to x on both sides. I would have a 2. Let's be careful again, we want to solve for dx. So multiply both sides by dx, divide both sides by 2, and you'd have dx equals du over 2. We're going to substitute in the original integral for u, and we're going to substitute in for dx. So when I rewrite this integral here, I'd have the integral of 2 over, instead of 2x plus 1, I'd have my u. Instead of dx, I'd have my du over 2. Notice what happens. The 2's simplify, and I end up with the integral of 1 over u du. Well, that's the natural log of the absolute value of u plus c, so the last step is back substituting for u. This is going to be the natural log of the absolute value of 2x plus 1 plus c as our final answer. Again, that's the natural log of the absolute value of 2x plus 1 plus c as our final answer.